Imagine this scenario. Two twins are born on the same day. One stays on Earth, living a normal life. The other spends years traveling on fast airplanes and orbiting satellites. When they finally reunite after all that time, they're no longer the same age. Now, this might sound like something straight out of a science fiction movie, but it's not. This is a real phenomenon called time dilation, a core concept from Einstein's theory of relativity. And the strangest part, it's happening to you, even just a tiny bit, every time you fly. Welcome to Planet Secrets. Time dilation is one of the most fascinating and counterintuitive effects predicted by Einstein. It essentially says that time isn't a universal constant. It doesn't tick at the same steady speed for everyone, everywhere. Instead, the flow of time can be altered by two major factors: speed and gravity. The faster you move through space, the slower your time runs relative to someone who is stationary. And the stronger the gravitational pull you experience, the slower your time runs. So, time isn't this rigid, unchangeable thing we imagine it to be. It's flexible. It can stretch, bend, and change depending on where you are and how fast you're moving. Now, let's get to the really mind-blowing part. Think about being on an airplane, cruising thousands of feet in the air at around 900 kilometers per hour. You might think that because you're moving so fast, your time should be slowing down. And you'd be right. But that's only half the story. The other factor is gravity. At that high altitude, the Earth's gravitational pull is slightly weaker than it is on the ground. And weaker gravity actually makes time speed up. When you crunch the numbers, the effect of the weaker gravity is stronger than the effect of the plane's speed. So, the net result is that your time runs just a tiny bit faster when you're in the sky. You are literally aging faster than the people you left behind on the ground. How do we know this is true? Scientists have actually proven it using what are called atomic clocks. These are the most precise timekeeping devices ever created by humanity, accurate to within a second over millions of years. In a famous experiment, they synchronized two of these clocks. They left one on the ground and put the other on a plane that flew around the world. When the plane landed and they compared the clocks, they were no longer in sync. The clock from the plane was ahead by a few nanoseconds. It's an incredibly small difference, far too small for us to ever notice in our daily lives. But it was real and measurable. It was concrete proof that time is not absolute. So every time you fly, you gain a tiny little time bonus, traveling microseconds into the future. This isn't just some abstract scientific curiosity either. It has very real, practical applications that you probably use every day. Your phone's GPS, for instance, would be completely useless without correcting for time dilation. GPS satellites are orbiting the Earth at very high speeds, about 14,000 kilometers per hour. And they're also in a much weaker gravitational field than we are. Because of these two effects combined, the clocks on those satellites run about 38 microseconds faster every single day compared to clocks on Earth. If engineers didn't constantly correct for this difference, the positioning errors would accumulate rapidly. Your GPS would be off by about 10 kilometers every single day. So, the next time you use Google Maps to find the nearest coffee shop, you can thank Albert Einstein. His century-old theory is what makes your modern technology work. Now, let's go back to that twin idea, but let's take it to the extreme. This is the famous twin paradox. Imagine one twin stays on Earth while the other hops on a spaceship and travels close to the speed of light. For the space-fearing twin, time would slow down dramatically. It might feel like only a few years have passed, but when they return to Earth, they'd find that decades have gone by for their sibling. Their twin on Earth would be significantly older. This isn't just a thought experiment. Astronauts on the International Space Station experience this on a smaller scale. Because of their high speed, they actually age slightly slower than us on Earth. Over a 6-month mission, they age about 0.05 seconds less than we do. It's a real, measurable effect. Space travel is, in a very literal sense, a form of time travel into the future. So, the next time you're on a plane, gazing out the window at the clouds below, take a moment to appreciate the physics at play. You're not just traveling across the globe, you're on a journey through time itself, moving just a fraction of a second faster than everyone else. Time is a far more mysterious and flexible concept than we ever imagined. If you enjoyed this mind-bending journey into the nature of time, make sure to subscribe to Planet Secrets. We have so many more mysteries of science, space, and the universe to explore together. Thanks for watching.